Alright, this is a set of mini tutorials that I'm going to do on the AVHC or arc voltage height controller for the Torchmate CNC. This is probably going to be in particular more useful to those of you that don't have it yet or haven't set it up yet. Those of you that do have it can easily follow the manual and have the equipment, the electronics in front of you to play with so that you can figure it out. But let me take you through some of the screens, the navigation screens. This is the main screen after you power on your AVHC. And mine is kind of hidden under this cabinet, but I've zoomed in this close so that I can show you this panel here. So current voltage will change as you're cutting. This is a number that you're going to want to watch often, especially when you're first setting up your parameters for new material that you're cutting. Voltage, that its target voltage right now in this setting is 76, and it's going to try to maintain that voltage by raising and lowering the torch. If the voltage is too high, it's going to lower the torch. If the voltage is too low, it's going to raise the torch. So for instance, if I was cutting at 115 inches a minute, sorry, not 115 inches, if I was cutting and I noticed that this voltage was at 115 while in manual mode and I had the right cut height, I'd want to raise this number, the target number. Otherwise, what will happen is when you go and put it in auto mode, it's going to try to drop the torch to meet the voltage, and you'll probably end up dragging your torch. Currently my cut is disabled. If I were to hold down my cut button, for instance, and turn it on, you see this light come on. Now the cut is on and you can see the cut message has gone away. I'm going to turn it off for our purposes right now. The other thing to notice is that you're in manual mode. When I cut small objects, especially things with little circles and just little parts that are no more than a few inches wide, I'll always cut in manual mode. Because when you're cutting holes and things like that, you typically are cutting them slower than the recommended voltage, and I'll end up dragging the torch or something like that. And so I don't want to do that. So I cut in manual mode very often. I still like it in manual mode because it raises the torch up about 3 or 4 inches off the plate before it moves to the next spot, avoiding tip-ups. So I'm going to cycle down through the screens. Cycling up or down, it doesn't matter. So the very first thing that you'll do, now you have to realize that this is a profile. You can store up to 16 profiles, I believe, in the AVHC. And so the current profile that I have set has a pierce height of 0.15. This is a spec I get from my Hypertherm manual. I don't know if other plasmas provide this information, but this is where you will set your pierce height, which should always be higher than your cut height. If you want to change it, you can press OK and then move that up and down and press OK again, and that will store the setting. It will not save the setting. So if I powered off the box and then powered it back on, it wouldn't save it unless I go to the profile and resave it. So the next screen is the initial cut height. Remember that your initial cut height is the cut before the AVHC starts reading in automatic mode. If it stays in manual mode, it'll stay at this height. If it goes in automatic mode after your delay that is programmed in another section, it'll start adjusting the torch up and down. Jog slide, I can manually make my torch go up and down. I have only had to use this option when I found my AVHC sticking. When you do the jog slide, I believe the torque value is, I think the default torque value is 15. I know that you can bump the torque value up and jog that up and down, and that's how I was able to test my AVHC and tell it that it needed cleaning. That's the only time that I've used the jog slide. Now, on this section, you can either change it to manual or auto. This is where you change that setting, and if I were to go back up now that I changed that to auto and go to the main screen, you can see that it is on auto. So I'm going to put this back in manual because I'm usually cutting small parts, and so I'll keep it manual unless I'm cutting larger parts myself. That's just a preference. You have a setup menu, which I'll go over in a minute. And this is my current profile for 16 gauge cold rolled steel, basically. If I want to change the name of this, I can press OK, and then I can cycle up and down through the different numbers and letters and spaces and stuff and end up typing that, which is a little time consuming, but once you set it up, you know, you're done. Oops, let's go down. And then if you want to save the profile, if you make any changes, you come in here, press OK to save. It's going to double check which profile you want to save it to. Press OK again to save. You can change the name again if you want. Press OK to save again. Oops. I accidentally pressed OK thinking I was supposed to save. I'm supposed to hold OK to save. So now I'm missing a letter. So let's go ahead and put an E in there. Press OK to that. And I'm going to hold OK to save. So now it's back to the Save Profile screen. So those are all the screens minus the setup. So the setup menu, which is also tied to this particular profile, I'll go into that. Oh, use OK to move enabled. This is the setting that I need for my particular setup, and it's probably what you'll need too. Use Pierce Complete enabled, so you can enable it, disable it. You can set a pierce delay. So if I were to set up a 1-inch plate profile, my pierce delay would obviously be much longer than 0.1, but with 16 gauge material I really don't need that big of a pierce delay. Sensing delay, this is 0.5. I'm not going to cover that right now, but we can look at that here in a minute on the book specs and program that to what you want it to be. Touch torque. Now this is where I was saying the default is 15. You can bump this up. However, if you're having to bump it up higher than this to actually move your torch, something is wrong. And you're going to break something if you continue to use it in a state where it's higher than 15. So don't use this higher than 15 for maybe some other than some testing. Like I said, I had to do it once under Torchmate's recommendation. I think they had me bump it up to 18 and then do an auxiliary on, auxiliary off, and that allowed my torch to drop when previous it wasn't dropping, and that told them that my, the lead screw and everything on the AVHC was dirty and I needed to take it apart and clean it, which I did, and it fixed the problem, and I ended up bumping this back to 15. And then we can return to our main menu. So each profile has all of those settings. It's really not too bad. And you'll want to save these settings. So if I go into current profile and I click OK to change, you can see I have a 1/4 inch. By the way, I cut almost everything in mild steel, so I don't put steel on these. I do put aluminum if I have an aluminum profile, as you see, but I'm cutting almost all the time everything out of steel. So I have 1/4 inch, 10 gauge, 1/2 inch, 3/8 aluminum, 12 gauge. I have a company that keeps coming back to me with some signs, and I created a profile specifically for their signs because they're kind of hardened steel. They're rock blades, and I ended up cutting them, and I ended up tuning the voltage and everything specifically for their blades, and so I ended up storing a profile because they come back often. 3/16, and as you can see, I've only programmed 8 of them in. I may need to program 1 or 2 more, but that's pretty much what I cut most of the time. So let's go take a look at the 3/16 inch profile. Now I've loaded that. My voltage, you can see I have set at 132. Right now I'm currently in auto mode, cut is disabled. Pure side is still 0.15. I believe that's a book spec. Can't remember for sure anymore. 0.09. My cut height should actually be 0.06, but I'm going to show you why I'm doing 0.09 here in a second. Jog slide again, auto mode, setup menu. If we go through the setup menu, you can see that these settings are all pretty much the same, except my pierce delay is 0.5 instead of 0.1. So we'll go back to the main menu, and that's it. So one of the very first things you're going to want to do is program your most common pieces of material in here so that you don't have to guess every time or go through the voltage and line speed tests every time you're trying to set this up. This is probably particularly important for plasma cutters other than Hypertherm. Hypertherm is great at giving you charts, but from what I've seen online, a lot of the other plasma companies are not. So you'll want to record these. I even record this information in at least my voltage and cut speeds in a chart just in case something were to happen to this. I would at least have that information. Okay, so one thing I did mention to you is that my initial cut height is 0.09, and let me show you why. Typically, I'm cutting on my table. As you can see, here's various parts that I've cut out, and like I said, I do cut a lot of small parts. So I have two slats that are 2 inches apart. If my torch comes down, especially on thin material, and it touches off of this area, there is enough torque there, and you probably can't see me flexing this, but I can flex this just a little bit, and within a few thousandths, I'm flexing this. So if I put it at 0.06 and it comes down and it hits one of these areas and pushes down on the plate, and then the plate rebounds, then I'm not actually coming back off the plate at 0.06. And I found that 0.09 actually gets me a little closer to where I want to be. And that's one thing you'll have to test on your machines based on how far apart your slats are, what kind of material you're cutting, what your torque settings are set at. Again, when it comes down and touches off, you know, if it hits right here, it's not going to flex. If it hits right in here, it is possible that it will flex a little bit. And again, you probably can't see me really flexing this in the video, but it does flex. And so you just have to account for anything like that and make the adjustments in your initial pierce heights, your cut height, your initial pierce height, your cut height, and your voltage. So again, I usually go just a few thousandths above the recommended initial pierce or cut height, and then I let the AVHC take over from there. Or I do cut in manual mode, and it's usually about right. Okay, in this portion of the tutorial, we're going to check my AVHC's current settings and make sure that the initial pierce height and cut height are what I expect them to be. Now, I'm going to put this in the weakest part of my table, meaning between two slats. So I have my torch currently above two slats, so if it's going to push the material down, it's going to do it the most in this location. I can do it anywhere on the table, but for the sake of this tutorial, I'm doing it as close as possible here. So let me change my current profile on my AVHC so that I'm actually editing the 16 gauge profile, which I now have loaded. I'm going to keep my cut off for this test, and my initial pierce height I put as 0.09, which should really, my initial pierce height should be 0.15. My initial cut height should be 0.06 is what the target is, but I ended up setting it to 0.09. So what I'm going to do is go to my aux panel on my driver software, and I'm going to turn the plasma on. It's going to give me a warning, are you really sure you want to turn it on? Because if your cut is turned on, it'll fire the plasma. So it drops, and you saw after the 0.1 that it dropped to what it should be its cut height. Now what I'm going to do is I'm going to take out a filler gauge, which you can pick it up at any auto shop, like Pep Boys or whatever. And I'm going to run the filler gauge under there to make sure that the initial cut height is, not the pierce height, but the cut height is what I want it to be at. So on my filler gauge, I don't have a gauge that's thick enough for my cut height, so I'm using something close, 0.03 and 0.032, so it's within 0.02 of an inch of where I'm supposed to be. I'm just going to try to run that between the torch and the plate to see if my cut height is right. And as you can see, I can slide that right under, and it is a tight fit. Let me come over from the right. Let me actually come back here and approach from the side. And if I approach from the side, you can actually see I'm having a tough time, and when I push it in, it's actually pushing the plate down, so I may be just a little bit too tight. So let me adjust my initial pierce height by just a little bit and retest that. So let me go down, not my pierce height, sorry, my initial cut height. So I'm going to bump it up to 0.11. I'm going to turn the plasma off, turn it back on. And by the way, I raised it from 0.09 to 0.11. And if I run my filler gauge under this now, it's about a perfect fit. So that's the height I want to be cutting at. And so, again, as I said, because of this is the weakest spot between my slats where the material is more likely to flex than at any other point, that's where I want to run my initial test from. And that comes out right. So my initial pierce height I'm not too worried about, but if I had to actually adjust my initial cut height by 0.05 up higher than what it should be, then I may want to do the same thing with my pierce height, and you may want to do the same thing. And I would go ahead and test this on various materials. For instance, 1/4-inch plate's not going to flex as much, but just double check your initial settings, and you'll kind of get an idea of what your AVHC is like, and you can make your adjustments appropriately. One thing I would recommend doing, I used to try to clamp my material, and that was a major pain, but I ended up buying this magnetic clamp at a welding store, and it has been one of the best things that I could do. So it makes attaching to your material very simple. I wish I would have done it a long time ago, but I would recommend getting one of those, just a side note. One of the first things you need to do when setting up your AVHC, especially if you don't have any charts from your manufacturer to put you in the right range of where you need to be as far as speed and voltage, is you need to do a line speed test. And you will do this with the AVHC in manual mode after configuring your initial pierce height and cut height. And in manual mode, you can go and open up one of the files that Torchmate provides for a speed test. Now, in my particular instance, I modified that file so that I'm doing 5 inches per minute increments, meaning I'm going to cut at 150 inches a minute, then 145 inches a minute, then 130 inches a minute, down to 105. So I modified this particular cut test to suit my needs, and you may need to do the same. You're not going to want to cut 150 inches a minute at 45 amps on 1/4-inch material, for instance. So with that in mind, I turn my plasma cutter down to 30 amps. I have a 45 amp tip there. I turned it down to 30 amps because at 45 amps with fine cut consumables on 16 gauge material, I get a lot of dross because you're supposed to cut faster than that, but I don't let my table go faster than that, for just in case it slips and things like that. So what I'm going to try to do is cut at 30 amps and find the most optimal speed on 16 gauge material with fine cut consumables. Again, I'm cutting at 150 inches a minute down to 105 inches a minute. What we'll do is we'll take that plate as soon as it's done and try to find out which one is cutting the best at what speed, and then you run a voltage test at that speed, and then you have your basic voltage and speed for the amperage that you have set for your tips or your nozzles. Alright, here are the results of our line speed test. The bottom was cut first at 150 inches a minute, moving down in 5-inch increments up to down to 105 inches a minute by the time we reach this end. It's kind of probably hard to tell in this video, but you can see that the cut quality as you get toward the top is worse inside of this actual line here. And if we were to flip this over and look at the dross on the back side, we can see our results. At the top you can see the dross that we have, and it gets progressively better as we get towards the faster cut speed on the bottom, which is 105 inches a minute. Again, my tip that I'm using on my plasma is rated for 45 amps, and at 45 amps on 16 gauge material, you're supposed to cut much faster than 150 inches a minute. I don't want my motors to slip or anything like that, or take any chances while I'm cutting material, because it still can be expensive. So I'm trying to cut at 150 inches a minute or slower with my 45 amp tips, but I have to bump down the amperage, and there are no charts for that that I've seen. So that's why I'm doing this. So at 150 inches a minute, I think I'm getting my best, cleanest line, and as little dross as possible. So I believe that's what I'm going to do. I still do have a little bit of dross there, and I may bump it down to just slightly below where I'm at, but I'm actually pleased with those results compared to what I've been getting at 45 amps, which is closer to the amount of dross that you see up here. So the next step is to take our speed, which is 150 inches a minute at 30 amps, and to go and do a voltage test. Now I did a voltage test similar to the one I'm about to show you, but my voltage is actually a bit higher. The example I'm about to show you was done on 16 gauge material at 45 amps. I just didn't want to re-record it at 30 amps, so I'm going to use the footage that I already created. On screen is the voltage test as provided by Torchmate. Pay attention to the current voltage and notice how stable it is on a straight line. This gives you a good baseline, and you should never set your voltage below that number. However, I prefer to do something a little more real world with lettering, arcs, circles, things that force the motors to ramp up and ramp down, because they do ramp up and ramp down, which means they're not cutting at the optimal speed or your feed rate as programmed. There are other settings also for arcs and circles that you can set, and in my case I have them cutting at about 60 to 70% of the normal feed rate, meaning I'm cutting them at about 90 inches a minute rather than 150 inches a minute. All of these things affect the way that the voltage is read by the AVHC, and as you can see in this extreme example, the voltage is all over the place. If you cut thicker material at slower speeds, you will not see such an extreme jump in the voltage, but I wanted to give you the most extreme case because I feel it may be the most useful. On screen, on the torch, I have a shielded consumable. This shield is something new. Previously, when using fine cut consumables, I was not using a shield because I didn't know there was one. Most of my other nozzles are shielded anyway, but with the fine cut they were never shielded. So you have to watch the voltage, try to take an average, and then run with that. However, if you miscalculate your voltage, or you dwell in a corner too much, or the material is obliterated underneath the nozzle, which happens on thinner material easily, your voltage can rise and then the torch drops, and when the torch drops it can drag in the plate, and there's no place for the molten metal to evacuate, so it ends up destroying the tip. With a shield I'm not as concerned about that. However, if you're cutting thin material, you may want to bump your voltage up just a little bit more than what you're seeing on the average, just in case you come to a corner or where you're changing direction and you want to prevent a problem like that. So for instance, if I had an average of 73, you may want to bump your voltage, as you see on screen, up to 76. And as you continue to mess with this, you'll fine-tune what you should have everything set to, and you want to keep a log of that. Keep a log of what your feed, your material is, what nozzle you're using, what amperage you're using, what your feed rate is, or how many inches per minute you're cutting, and then finally what your voltage is. If you can keep a log of these things, you shouldn't have to do this more than once or twice when setting up new material. Now if I go to cut some material that I'm unfamiliar with, like aluminum, then I would need to go and set this up. And again, you can store some of these profiles and most of these settings inside of your AVHC itself, but you'll still want to keep a log of things.